Okay, the other day we talked about linear functions, and we're talking about any time where you have an expression. So let me write that expression, x squared minus 4 or something. That's an expression, and you give it a name, f of x. It's now a function. So the function f of x is described by x squared minus 4. This is not a linear function, so I'm going to put a line through it. Okay, not linear. I just wanted to remind you what a function looked like. What makes a linear function, what makes a function linear, I should say, is the fact that the graph of a linear will be a straight line. Okay. So, as we know, those functions look something more like this. F of x is equal to 6x minus 4. So there's a linear function for you. Now, we can also write this linear function as a linear equation, okay? And the reason we're going to want to do that is then it allows us to manipulate both sides of the equation and do all kinds of things with it. So let's go back. Let's forget function notation for a minute, and let's go back to a linear equation. All right, and the only difference is I've replaced f of x with y. Okay? Now when we talk about this equation, we can talk about solutions. Okay? So here's a vocabulary word for you, solution. A solution to this, or any equation, is, in this case, the xy pair, because this is a two-variable equation. It is the xy pair that makes the equation true. Okay, so we've just kind of expanded our original definition of solution. We want to make sure the equation comes. Okay, I may have a little skip here in the audio recording. I'll try and fix it if I did. But I'm just going to say, is negative 3 comma 5 a solution? The answer is no. So if you caught all the video and you're good to go, you can go ahead and skip. But if I miss some video or some audio, it's impossible for me to go back in the middle and fix it. So here I'm going to try and fix it at the end. We were talking about solutions being the ordered pair, x and a y combination, that makes the equation true. So when you look at the question, is 1 comma 2 a solution? I'm giving you an x and a y value. You're going to make those substitutions back into the original equation. You're going to keep the left and the right side separate. Okay, left stays on the left, right stays on the right. Just bring everything down, down, down until you come to a conclusion. Is it a true statement or a false statement? In this first case, it was true that I found that 2 is equal to 2, true statement, so I said yes, the 1 comma 2 is a solution. In the second case, I said no, I found a false statement, so it's not a solution. Alright, so hopefully I get the audio hooked up a little better next time. Let's try another one. Okay, we had this nice equation, y equals 6x minus 4. This is a great equation. It's in what we call a slope-intercept form. Okay, and this is going to be our favorite one. We're going to use it all the time. In general, y is equal to mx plus b. Okay, so you should always be able to write this. You should have your x and your y, but we're going to be able to find what the m is and the b. Now what do those stand for? As you probably remember, m is our variable for slope. So that line, that's the graph of this equation, that line has a slope. We'll call it m until we find out what its value is. The b has a meaning also, and you'll remember this is the y-intercept value. And technically the y-intercept is written as 0 comma b. It's a point on a graph, so it has to be an ordered pair. Okay, and let's talk about y-intercept a little bit more. What is a y-intercept? Make sure we have a good understanding. The y-intercept, of course, is going to be wherever the graph of your line crosses the y-intercept. So if I have a line, it looks like this, and I ask myself, I need some gradations here. Okay, ask myself, where does that blue line cross the y-axis? Remember, this is the y-axis, and the blue line is crossing right here. So that would be my y-intercept. And in this case, you know the x value is 0, so I'm going to write 0, 2. Okay, so for every y-intercept, you know the x is equal to 0, and that will be true for every y-intercept. It's also interesting to go back and forth a little bit. If we look at the x-intercepts, okay, right here where the graph crosses the x-axis is an x-intercept. Okay, so forgive me for a little bit of shorthand, maybe I'll write it out. There's an x-intercept. The thing that's common to any x-intercept is they all have a y value, 0. So this one happens to be x is 2, and the y is always 0 at an intercept. Okay, so there are my x and y intercept. But for slope-intercept form, this one in particular is y. Okay, so make sure you're always talking about the y-intercept. It's very easy to get confused when you start graphing. Alright, so we have these y equal mx plus b. We can go back to our 6x minus 4. It's very easy then to look at this and say, oh, the slope of this line would be 6. The b value is negative 4, which makes the y-intercept value 0, negative 4. Okay? So we're going to be very particular about our notation. B is negative 4, but if you're asked the question, what's a y-intercept, then you have to put it in an ordered pair. Okay? Because intercepts are points on a graph. Okay, and if you just give me negative 4, that doesn't mean a lot on a graph. So, what are we going to do with our slope-intercept form? Next page. Okay, one of the things we can do is we can easily write an equation of a line if you tell me what the slope is and the y-intercept. So say someone comes up to you and says, okay, the slope is equal to 5, and they also tell you the y-intercept is a point that could be labeled as 0, 4. And then the question would be, write this equation of a line. Now remember, we like to use y equal mx plus b. And I will tell you, anytime you are in doubt, just write that equation down and something good will happen. Alright, so what good is going to happen out of this? Well, I know slope is 5, so I'll write y is equal to 5. Leave the x, leave the y, and add the y-intercept right here. B is equal to 4. So I'll put a 4 here. Okay, so that's the answer. I have an equation of a line. So when I'm asking for an equation of a line, I'm asking for this whole equation. Okay, there's no answer, there's no solving it. It's an equation, okay, that you're trying to come up with. All right, the second thing that you might be asked to do is to write an equation of a line given a graph. Okay, so here's a pretty picture of one, but I'd rather have it as the equation. So what you're going to be given would be a graph. It might look like this. We have your x-axis, you have your y-axis, and it has a graph on it. Let's see if I can come up with one fairly decent. And some marks for you. Something like that. Okay? And we want to write an equation of a line given a graph. Okay, well, let's see. We're going to need some steps for this one. So the first step would be to find the slope by picking 2 points. Okay, it looks like the audio cut out again, so I'm going to have to try one more time. Maybe it's a little too loud, so I'll come back and do it later. Okay, let me go ahead and try and talk you through this when I've already got it written on here, because there's no way to fix that without redoing the whole thing. But we were talking about writing the equation of a line given a graph. We decided the first thing to do was to find the slope by picking 2 points. So when I look at this graph, I decided, gosh, the points really did line up a little better before, but this first point, 0, 2, nice point to pick because of course that's going to give me a y-intercept. And then this point here is another one that looked like it was, well, it did before everything shifted, looked like it was right on the coordinate -2, -1. So bear with me, those are my 2 points that I had found on this graph. I take those 2 points over here and I start doing my calculate the slope, okay, making sure I'm taking the y minus y and then x minus x and coming up with a slope of 3/2. Okay, so I found the slope. That was my first step. The second step is to find the b value. But remember, the b value is going to come from a y-intercept, and on this graph I was able to identify the y-intercept by just looking at the graph. That was a 0, 2, so that leads me to understand that b is just the number 2. Okay, so now I have m, I have b, so my third step, I went way over here just to find a clean space. The third step was just to substitute those two values, the m and the b, into our y equal mx plus b, and come up with y is equal to 3/2 x plus 2, describing the line in the graph here. Alright, let's see what else. Alright, I'm going to let you guys try this one. I want you to find the equation of the line for the graph shown. Of course, I have my x-axis and my y-axis, and do the best you can to approximate the 2 points and get you started. I'm going to pause it and let's see how you did. Okay, I'm coming up with an answer. Y is equal to -4/3 x plus 4. If that's what you got, go on to the next slide. Otherwise, I'd like to go ahead and explain it. When you tell me find the equation of a line, I know I'm looking for something that looks like y equal mx plus b. So I need to find the m, and I'll need to find the b. I'll start with slope by picking 2 points. I found the point 0, 4, and I found a second point 3, 0. Intercepts are particularly nice to work with because they have the zeros in there. Alright, so when I set them side by side, I can start calculating slope by lining up my y's, lining up the x values, subtracting the y value here minus the y value here, and take that over this x value and then subtract this second x value. So you do the subtraction, you come up with a slope for m is equal to -4/3. And then, because one of the points I could identify was already the y-intercept, I can find my b value right there. B is 4. So now I know m, I know b, I'll just put those back in. Y is equal to -4/3 x plus 4. And that's the equation of the line. You're done. That's how you answer the question. So we can move on, okay? Okay. Another question I might ask of you is to be able to write an equation of a line in a slope-intercept form. Now I'll give you an equation, it's just not in that same form that we want it in. So remember, the slope-intercept form is going to look like y equals mx plus b, but maybe I've given you something entirely different, and I've given you something that looks like 2x 5y is equal to a -10. Okay? So that's obviously not in slope-intercept form already, and all we have to do, the trick to all of this, is solve for y. So this is why we were practicing those literals. Okay? We're going to solve for y. We won't get a number, but we'll get an expression with some other variable, in this case x. So what do? We want to get the y by itself, so we'll start by getting the term with y by itself. So subtract 2x from both sides. Okay? And what you're left with is 5y is equal to -2x minus 10. That's all good. And then I might decide to divide by the 5 on both sides. Okay? So that leaves you with the y that you're looking for all by itself. That leaves you with -2/5 times x and -10/5, which I'll reduce to a -2. Okay, so everything on the right got divided by 5, not just the 2 and not just the 10. They both have to be. And that is what we're looking for. And the great thing about that is, and the reason we like this, is now that I have this equation in this way, it's very easy to identify. A next question could be identify the slope. It was hard to do when we were up here. Okay, but down here, identifying the slope is very easy. -2/5. And I could ask for identify the y-intercept. Again, hard to do up here, easy to do down here. -2, and remember you have to put it in an ordered pair. Intercepts are a point on a graph, so they have to be an ordered pair. Alright, so that's another question I could ask you, and you should be able to write this equation in a slope-intercept form. Makes our life a lot easier then. One last thing I want to show you, next one. And we're talking about making sure we can graph these linear equations. Okay, so the first one we're going to look at is if I've already given you an equation that's in a slope-intercept form. I talked before about how nice this is for us because we can easily identify a slope, 3/2, and easily identify the y-intercept. At least the b value is 1. So slope, I'm going to remember, is a rise over run. And the y-intercept is really the ordered pair, 0, 1. Okay? Remember, x is 0 when you have a y-intercept. So how do I use these two things together to plot a graph? You're going to start with this, okay? Always start with the y-intercept. So you're going to take coordinate graph, and the first thing you'll do is plot this y-intercept. So 0, 1, you go right here, 1, 2, 3, and 4. Okay, let's get some grids on there. And then we're going to take a look. So number 1 is to start with y-intercept. Number 2, use this rise over run. And what does that mean? If the rise over run is 3/2, I could say the rise is equal to 3, while the run is equal to 2. So I'm going to start at the point I've already got, okay? And I'm going to rise 3 spaces, 1, 2, 3. And then I'm going to run over 2 spaces. So 1, 2, puts me right here. So that's my second point, because I went up 3 and over 2. And then all you have to do is connect those 2 dots. Now, to be more accurate, you can go up 3 again from here, up 3, over 2, and get even more accurate. But it should end up on this same line. You could also go down 3, so down 3 and left 2, okay? And also get on the same line. So that's a great way to graph it when you're given y = mx plus b. The second way, okay, would be if you're given the what we call a standard form of the equation. And we had looked at this before, 2x plus 5y is equal to a -10. And my favorite way to graph here is to look for intercepts, okay? So here's another way to talk about finding intercepts, okay? So when I want to find the x-intercept, that of course is the place on the graph. Trying to remember what this one's going to look like. It's going to look something like this. An x-intercept is the place on the graph where it crosses the x-axis, and a y-intercept is the place where it crosses the y-axis. At the x-intercept, you know y is equal to 0, and at the y-intercept, you know x is equal to 0. So they kind of have this little flip-flop relationship going on there. So we're going to make use of that and find the intercepts. To find the x-intercept, set y equal to 0, and you'll be able to solve for x. So let me do that down here. 2x plus 5y, oops, we said y was 0, put a 0 there, is equal to a -10. 2x is equal to a -10. X is equal to a -5. Let me put it in an ordered pair so it looks like an intercept, -5, 0. That's my x-intercept. Okay. Then I want to go and find my y-intercept. I'll go to the next page. And I'll do that by setting x equal to 0. So remember I had this equation, how'd it go? 2x plus 5y is equal to a negative 10. I'm going to set x equal to 0, so 2 times 0 plus 5y is negative 10. This allows me to solve for y. 5y is equal to negative 10, and y is equal to negative 2. I'll put it in an ordered pair, 0, negative 2, and I have a y-intercept. Okay, I have 2 points. I have that y-intercept, and I had also found my x-intercept. What was it, negative 5, 0 was my x-intercept. Alright, I have 2 points. I'll plot both of those on my graph. It's an x and a y-axis. Let's see, negative 5, 0 is right here. Negative 0, negative 2 is right here. And all I need are 2 points to draw a line. So there it is. I almost got it. And that's all you need to do. So when you have that kind of ax plus by equals c form, it's called a standard form, it's nice to use intercepts. It's not the only way, it's the way I'm recommending right now. Okay? And all you have to do then is connect those 2 dots. Alright, let's give you one to try. Okay, I want you to try this one. I've given you 3x minus 4y is equal to 12. And I want you to go ahead and find the intercepts so that you can graph this line. I'm going to pause it, so are you, and we'll check our answers. Alright, my graph looks like this. It's a positive slope. It has a y-intercept negative 3. If you want an explanation, that's great. Otherwise, I just have one more problem for you to try on the next slide. You can go ahead. But in this case, I wanted to find the x-intercept, so I'm going to set y equal to 0 from this original equation. So take that, set y equal to 0, set y equal to 0, and you get 3x equal to 12, so x is 4, write it as an ordered pair, so that's your x-intercept. And put it on the graph. 4, 0 is this one right there. Okay. Then you're going to do the other one, find a y-intercept by setting x equal to 0. So take that same equation, set x equal to 0, solve for y, put an ordered pair, and graph it. And then all you have to do is connect the dots, and you have a line between those 2 points, and that's the line of that equation. So I have one more thing for you. Next page. I want you to go ahead and graph the line from the equation y equal negative 4/3 x plus 2. I'll pause it and we'll check. Okay, I got that picture right there in red, and what I did first was I started right here and I said the y-intercept is 0, 2. So that went on my graph first. Okay? Once I have this point on, I can start here and then go down 4 and over 3. There's only one negative, so I'm going to put it on the 4. And then I'm going to go positive 3 direction. Okay? Because a negative over a positive is still, everything's negative when you put them together. So I went down 4, and then I go over 3. Maybe I missed that one. Oops. So I go over 3. 1, 2, 3. It's more like here. I'll try that again. It's over that way a little bit. So I did miss it a little bit. So that's a better answer. Okay? So remember, start with your y-intercept and then go down and over. Also could have gone up and to the left, and that would have been saying the slope is 4 over negative 3, which is the same thing. It doesn't matter if I put the negative on the top or the bottom. Alright, we'll see you in class.